Welcome back to another UGA Big Data tutorial. Today we're going to be giving a tutorial on how to run a Hadoop MapReduce job on the GACRC cluster. To get started, we need to go ahead and connect to the UGA campus network to access the services. So to do that from a ISP such as Charter or Comcast or AT&T, we need to go ahead and use the Cisco VPN client to do that. So once you've done this, it's available for Windows, Mac, and Linux. Once you've done this, we can go ahead and move this over to the side. Our next step is to open up a terminal window to connect to the GACRC's Hadoop cluster. So to do that, we'll just go ahead and bring up a terminal window here. And I've already created an alias for this, and I've already created a public and private key set for this, so we do not need a password to log in. So we'll just type in SSH. And this logs us into our Hadoop cluster. So a few things with Hadoop, we need to go ahead and understand the actual service of how the Hadoop cluster works. This is the name node, so when you type in JPS, it only shows the JPS service. Now, if you're running the head node and a compute node, you'll see about 6 different services. Hadoop runs its own file system. So in order to process data on the Hadoop cluster, you need to go ahead and transfer your files over to the Hadoop file system. We'll go ahead and take a look at that first. To access the Hadoop file system, we need to go ahead and type in 1 or 2 commands. You can either type in Hadoop, DFS, or FS. They're really the exact same thing, but I'll put an article down in the description. You can check out what somebody wrote about that. But they're in essence the same thing. I like to type in FS because it's simpler. Yeah, I'm here. There's a bunch of shell commands. You can go on this page, and there's a bunch of different commands you can use to interact with the Hadoop file system. So let's go ahead and show you the simple one. Just type in ls. And this will show you that I have nothing on the actual Hadoop file system. For our project, we need to go ahead and create an input folder. So I'll do that right now. I'll do Hadoop, FS, and I'll do a dash. I'll do make directory, mkdir, and we'll type in the directory name. So we'll name it input. Now we've created an input folder on the Hadoop file system. So to verify that, we'll go ahead and just go. As you can see there, we have one item found. That is our input folder. Now, there's nothing inside the input folder. We can list what's inside the input folder as well. We can do input, and nothing gets returned. Our test project we'll be demonstrating today has 2 output parts, but uses the exact same input files. So we'll go ahead and create those right now. As you can see, we created 2 separate output folders. So go ahead and verify that. We'll just do Hadoop. We'll go ahead and list our folders. So as you can see, we've created those 3 folders on the Hadoop file system. Our next step is to take a look at our project and go ahead and transfer our large file to the input folder. Create a project here called WebGraph. To give you a little bit of background on the project we'll be using today, we'll be using Dr. Ramaswamy's programming assignment that he did for our distributed systems class. So this project here is about mapping the in node and out node. So you have in nodes and out nodes, and basically you map the number to the amount of out nodes and in nodes. That's the first part. And I'll put all this stuff inside the project's files so you can go check this out. And then the other part is just to make a map from the actual node to all the corresponding nodes. So for this one, you'll have a long string. We'll go ahead and take a look at the project itself. So the project here contains a rather large file. It's a 77 megabyte text file containing those zeros and ones. So I'll give you what's a little bit inside that file. Do a head command. And basically, it's the same format. So you have it separated by a space in between the in node and the out node. So that's the file we need to go ahead and transfer to the cluster. So to transfer that file to the cluster, we can use many different commands. You can use a copy command, you can use a move command, but the one I found to be most useful is the put command. The put command will not delete the file on your local side, it will just copy it to the other side. So to do that, you just type in Hadoop fs-put, and you give it the local file name, and you give it the side you want to transfer it on. So we're going to be transferring it to the input folder, so just type in input. And it's going to head and move that to the other side too. So now to verify that, we type in Hadoop And as you can see, we have that file loaded onto the input folder of our Hadoop file system. Let's go ahead and take a look at the rest of the project here. We have a few folders here. We have the source folder. Our source folder has the 3 Java classes. We'll have one Java class that processes the input, and then we have the one for each of the 2 parts of the project. And we have our bin folder for the Java classes, and then our output, which you can get a few different ways. We'll go ahead and look at our makefile here. Got to explain some things about the makefile. It's a pretty complicated makefile, so go ahead and take a look at it. Our first compile option is to go ahead and remove the classes that are previous generated on compile. We also have to remove the actual jar file that we've created before, and we go ahead and make a directory inside of our bin file for our Java classes for part 1. And we have to do this Java compile option here. We give the class path, and for this, you need to go ahead and find the Hadoop core file. It's a jar file. You need to go ahead and locate that. It's different. It's in different directories on different systems, so you need to go ahead and make sure you link that correctly. Once you link that, you basically use the destination of where you want to save the classes to, and then you give it the actual classes you want to compile to that jar file. And then you create the jar file from the actual folder of the classes, and then you basically compile that and put it into the current working directory, which is the root of the WebGraph folder. So once you compile that, and we have an option here where if you type in make part 1, it'll automatically compile it for you and start running the program. You have to remove the Hadoop file system output folder when you start. So for example, this line here, you have to do this line before you can run a Hadoop job. It will not allow you to write into a folder that already exists. So basically, this is the recursive delete for the Hadoop file system. So you just include this when you run the project, and it'll automatically delete that folder for you. And then this is the Hadoop command that actually runs the actual project, the Hadoop jar part 1. So we're running the part 1 jar. The name is WebGraph. That's the name of the class. And we'll be running it from input, and then the output will go into the part 1 output. And our Hadoop file system will do a cat. You can either do a get command to get the file back, or you can just cat the entire file and redirect that to another output folder on the local side. We chose to done it this way. Go ahead and do make. Let's go ahead and compile that for us, and it's going to head start running the actual job. Now, while the job is running, you can go ahead and check out the actual job that's running. There's the Hadoop, the 530 port number. You can see the actual job. So go and refresh this page here, and we're going to see that we have a job in progress. So you can go ahead and click on the job that's running jobs. Click on it. We can see some information about the job, what it's mapping, and some other things here, some cool things. This will just allow you to see some of your options available when you're running the job, if there's any errors or anything like that. And the 570 will give you the actual cluster health and information about the cluster. So you can go and take a look at those too. And make sure you're on the UGA directory to use these services. Go back and see our mapping job. We're at 100% mapping, so we'll go ahead and let that finish. As you can see, the Hadoop MapReduce job has completed. And you can see we've done our cat command of the output file and redirected that to our local file, the output part 1. So we'll go ahead and look at that. As you can see here, there is 2 files. I've already run this before on part 2, so we'll go and just take a look at part 1. We'll do a head command. So as you can see here, this is our output. We did have a check new script to check these results, but I don't have that here with me currently right now. But that's a general principle, and we'll go ahead and take a look back at the Hadoop file system to see what type of files it generates over there. So we'll go ahead and type in Hadoop. We'll go and look at the part 1 outputs. So we'll do as you can see there's a file in there. It's called part-r-0. Basically, all you're doing is catting this file. You can do a get command to get the file, or you can just cat the file and redirect it to a local output. 2 ways to do it, totally accept for each one. Now, to delete your files on the Hadoop file system, you can do it a few ways. The most common way to do it is to do fs.rmr, which is the recursive delete, and you can give it your file name, so input. We'll go delete our input there. And it's going to tell us we've moved the input to the trash. We'll go ahead and do the same for the last 2. And we'll go ahead and take a look, and we've gone ahead and deleted those. And that's how to run a MapReduce project on the GACRC Hadoop cluster.